Yesterday, I recorded my whole geometry lesson without the top of the screen. I went to watch it last night and it was like half the screen. So you could just see my hand just to writing away. It was so bad. I was like, oh well, because somebody may need to listen to it and I'm not going to teach that again. So I'll redo it next year, I guess. All right. Pretty embarrassing though. Whatever. All right. Elimination method. I have not put in the quiz corrections that you guys turned in on Tuesday, so that is one thing that can bring grade up.
Will I get my quiz back since I took it?
Yeah.
Yeah.
I will make sure those are here tomorrow. I will make sure. I will make sure that I have your grades tomorrow. Okay. So check the tray. I'll make sure of that. All right. Elimination. First thing we have to do is multiply one or both. I may get them graded here at the end. I may do that real quick so that you guys can have them back today. What are both equations by a number to result in the two equations having opposite terms? Meaning like 3 and -3, 1 and -1, just opposite terms. The second step says that you're going to add the two equations together. Eliminating one variable. And then solve for the remaining variable. And if you don't mind, for sake of hand cramp for all of us, steps 3 and 4 follow exactly like steps 3 and 4 for substitution. So we'll just write same as substitution. Okay, so we've got the opportunity. We may not have to multiply anything. Step 1 may be done for us, right? It could be that you have to multiply one of them by something, or it could be that you have to multiply both of them by something to get a variable to eliminate. So let's look at this first example. So looking at the steps that we have here, which variable looks like we could possibly eliminate it? The y, right? We see both, it carries the same coefficient. So what could I multiply one of these by to get them to be opposite coefficients? -1. So I'm going to multiply, it doesn't matter which one, just choose one to multiply the whole equation by -1. It's basically distributing it, right? I'm going to multiply every term by -1. And that results in -5x minus 3y equal to positive 19. This second equation I'm not going to make any changes to, but I'm going to go ahead and bring it over and line it up so that I can do my addition. This all falls under step 1. Step 2 says add them together. So 8x minus 5x is 3x, while 3y and negative 3y are going to make 0. And 19 minus 25 is going to make negative 6. Now I have a one-step equation. I'm just going to divide by 3. And x equals negative 2. All right, and then now I've done step 2. This was all step 2. Step 3 goes back to the same as substitution. I'm going to take this variable information and plug it back into one of the originals. Does it matter which original? No. So just choose an original to plug. Instead of x, I'm going to use negative 2. So I'm going to solve my two-step equation here by adding 10 to both sides. That leaves me with 3y equal to negative 9. I'm going to divide by 3, and I get y equal to negative 3. This is all part of step 3. And the last and final step said to do what? Put it as a point, x comma y. And I'm doing that to show my point of intersection, right? Okay? You guys try this one. Don't let it trick you up.
Is this the last thing we're doing for this lesson?
I have a little bit more to go. Oh, were you gonna try to squeeze it?
Yeah.
No. Not worth it. The problem, you should have first realized that the 3 y's were already what? They were already opposite, right? So if they were already opposite, what step 1 was not needed, right? So I went ahead and added them together. 4 and 2 making 6x, the 3y and negative 3y making 0, and the negative 22 and 16 making negative 6, which resulted in the x equaling negative 1. Right? The next step was to take it and plug it back into one of our original equations, which resulted in our y being 6. Yes? Questions? None? Okay. I'm going to have to turn my paper on that note. I don't have enough room for the last little bit. Okay. Does everybody have this part? So the last thing I want to talk about is those special cases, such as no solution and infinite solutions. So that no solution and infinite solution. The only thing I want to make sure that I point out to say here is that this occurs when both variables are eliminated. So I want to take you over to the wall here just for a second. So I did this to show every year I get this situation where we get to this point and someone says, oh, it's 0, so that must be no solution. And that's not the case. 0 is a possible solution. Can we have an x equal to 0? Yeah, so don't get caught up in the situation of thinking about no solution and infinite solution and miss the fact that you can divide by 4 and you still have an x. The x still exists. It didn't go anywhere, right? Is everybody with me? That happens every year, so I just want to make sure I point out. If the x came down and still had a value here, it didn't eliminate. It can't be no solution or infinite solution. Everybody with me? Okay, so make sure it's occurring when they eliminate. Okay, so let's look at an example. All right, so I have 5x plus 3y equals 52, and 15x plus 9y equals 54. And when you look at this one, you think, okay, I need to eliminate one of the variables. Which variable would you like to try to eliminate? Just which one? Pick one. Y, okay. So if I want to eliminate y, I'm going to multiply this top one by what?
3.
Negative 3. Got to have the negative because I need the opposite sign on one of them, right? If one of them was already opposite signs, I wouldn't have to do that. But this one isn't. So then I'm going to multiply that out, and I get negative 15x minus 9y equal to negative 156. I'm not going to make any changes to the bottom one, but I am going to go ahead and bring it over. So 15x plus 9y equals 54. And I start to see that something there is definitely going on, right? So when I move to step 2 and I add these two together, 15x minus 15x is going to make what? 0. And 9y and negative 9y are going to make what? 0. So I end up with 0 on this side. And then I have negative 156 plus 54 is going to give me negative 102. So then I ask myself, is this a true statement? No, this is not true. If it's not a true statement, then this is no solution. The variables were eliminated, and I ended up with an untrue statement. You with me? Okay, I don't care which one you put on written work, no solution you can write out, or you can put the symbol, okay? Both are sufficient. Don't have to do both, okay? All right, and then let's look at this one. So I have 2x plus 3y equal to 15. and negative 4x minus 6y equal to negative 30. So when I look at this one, let's eliminate the x this time. What am I going to have to multiply 2x by to get it to be the opposite of negative 4x? Positive 2. I already have a negative, right? I already have a negative, so this one's going to be positive. Does everybody agree? All right, so I'm going to end up with 4x plus 6y equal to 30. And I'm going to go ahead and bring over the other one. Negative 4x minus 6y equal to negative 30. And I start seeing something's definitely happening here, right? So when I move into step 2 and I'm adding 4x and negative 4x, I'm going to get 0. And 6y and negative 6y, I'm going to get 0. And 30 and negative 30 is going to give me 0. Now, is that a true statement? Yes. So my variable's eliminated. I ended up with a true statement. Therefore, it is infinite solutions. Not all real numbers. Everybody's still getting hung up on that. I don't know why. Not all real numbers. Infinite solutions. Any questions about?
Yes, it's just going to be 0 equals 0, right?
You could have ended up with like 2 equal to 2.
How can you equal 2?
Just by different setups, it could have happened. Just some different setups. It doesn't matter what you end up with as long as there's no variable involved and the two statements are equal.
So like the number equal to the number?
Most of the time it will be 0 equal to 0, but I have seen some numbers show up in different weird situations. Okay, any questions? So you have substitution, graphing, elimination, and these special case situations. Yes? Okay. So you have the rest of the class period to work on your assignment.